So, hello students. Today we are going to do continuity and differentiability as the next chapter in JEE. This is the first question. Let the functions f and g be defined as piecewise function. The number of points in the real number set where f circle g of x is not differentiable. So it is not differentiable. That is what you have to see. So first we will find the piecewise function f of g of x. So first f of g of x will be for x cube. I'll make it here f of g of x function. G of x I will write as x cube. Then f of x cube will be, because it is less than 1, it will be x cube plus 2. So the first function will be x cube plus 2. But then the values of x should be less than 0. Then next we will make for 3x minus 2. F of 3x minus 2, g of x is this. And now in f, x is replaced by 3x minus 2 plus 2, which will give us 3x. But we have to see the bounds also. We will see different bounds. For that, we have to do stepwise. Then only you will understand. If I do directly, you may not understand. So first, I am making the piecewise function f of g of x. So I have to take x less than 0 because that is the domain of f. So when x is less than 0, you will have f of g of x, that is x cube. And f of x cube means, okay, I'll write here f of g of x is x cube, and f of x cube is x cube plus 2. So first piecewise, I will write like this. Now when x is greater than 0, when x is greater than or equal to 0, we have to take less than 1 also. And in that case, you will take g of x as x cube only. But then f will be x square, that is x cube whole square, that is x power 6. Now, the third one is when x is greater than or equal to 1. Actually, it is greater than or equal to 0 and less than infinity. Then in that case, the g of x function, we will take 3x minus 2. And f we will take x square, that is 3x minus 2 whole square. So this is how we get piecewise function. Now we will find the derivative of this composite function, a piecewise function. 3x square for x lesser than 0, 6x power 5 for 0 less than or equal to x less than 1. And lastly, 3x minus 2 whole squared derivative is 2 into 3, 6 into 3x minus. I have used chain rule. But this is for x greater than or equal to 1 lesser than infinity. Now we will see, they said F circle G is not differentiable. So first we will see at x equal to 0, what is happening. At x equal to 0, left derivative is 0, right derivative is 0. But if you take at x equal to 0, left limit, it is 2, right limit is 0. So what can we say? The function is not continuous because left limit and right limit are not equal. So the function is not continuous. That means the function is not differentiable at x equal to. So option 3. But what did they ask you? Did they ask you about x equal to 0? They said number of points. 0 is the only one point where it is not differentiable. So option 2 will be the correct option. I'll put the next question. So in the next question, what is given? F of x function is given to you is continuous at x equal to 0. X in the bracket means it is x minus greatest integer function of x. X in brackets is the greatest integer less than or equal to x. Then you have to find what is alpha. So because the function is continuous, left limit, right limit, both are same. How will you find the left limit or right limit, which both are same? X approaches 0. We are seeing at 0. Cos inverse of 1 minus x square sin inverse 1 minus x by x minus x. This is the limit. And then f of 0 should be equal to this if the function is continuous. Directly, if you substitute 0 for x, in some cases, we can substitute directly x as 0, not all. Limit x approaches 0, cos inverse 1 minus x square into sin inverse 1 by, take x common, you'll have 1 minus x square. So limit as x approaches 0, cos inverse 1 minus x square into sin inverse 1 is pi by 2 by x one minus 0 will be 1 only. In denominator, you can just keep x. So now, in order to find the limit, we will take and write it as cos inverse 1 minus x square by x into pi by 2. Let us take 1 minus x square as cos 2. So what will be x? Square root of 1 minus 4. That means I will have pi by 2 outside, limit of cos inverse 1 minus x square is cos theta. And x is root of 1 minus 4. And then when x approaches 0, here when x approaches 0, cos theta approaches 1. If cos theta is approaches 1, that means theta approaches 0. Cos inverse and cos are removed. Theta by square root of 1 minus 4. Or limit theta 1 minus cos theta is, there is a formula. 1 minus cos theta can be written as 2 sin square theta by 2. So when you take the square root, root 2 sin theta by 2. Here, numerator, you can divide by theta by 2. Denominator, you can divide by theta by 2. That we are doing because as per the formula, limit of this will be 1. And then you can cancel theta and theta out. So pi by 2 limit theta approaches 0, 2 by root 2. Or pi by 2 into root 2. Or it is pi by root 2. This is what we have. But this is when x approaches 0 from the right side. So we got the right limit. But if you take left limit, limit as x approaches 0 minus cos inverse 1 minus x square. And then sine inverse 1 minus x. By x minus x cubed. So we will have cos inverse 1 minus 1 plus x whole square. And then sine inverse of minus x. By 1 plus x minus 1 plus x whole. Now, why did I write that? Because what is x in the flower brackets is x minus greatest integer function of x. So when you are doing the right limit, my pen is not working. When you are taking the right limit, actually what is happening? X is greater than 0. So if you take x in bracket, it will be x minus greatest integer function of x. That is x minus x plus greatest integer function of x. These two will cancel. Greater than 0 means the answer will be 0. So greatest integer function of x will be 3. That's why what is happening here? We have written this as 0. And then we have only sign inverse 1. Here also we have written this as 0. Wherever possible, we are substituting 0. But now, left limit. If you take x in brackets, it is x minus greatest integer function of x. This time x is lesser than 0. So what happens? It will be minus of minus 1. That is x plus 3. So we are writing bracket x as 1 plus x. Here also we are writing this bracket x as 1 plus x. Here also we are writing bracket x as 1 plus x. And here also we are writing 1 plus. This is how we got this. Next step, I can write limit x approaches 0 minus cos inverse of 1 and minus 1 will have. X you can put as 0. So cos inverse. But sine inverse minus x I will write minus sine inverse 5. I will take out 1 plus x common. 1 minus 1 plus x whole square. So cos inverse 0 is pi by 2 minus sine inverse x. Here I will put x as 0. So 1 into 1 minus 1 plus x whole square. Now this I will write it as in the next page. Minus pi by 2 limit x approaches 0 minus sine inverse x by 1 plus 1 plus x into 1 minus 1 plus x. Because I am using a square minus b square. A plus b into a minus b. In doing so, I'll get minus pi by 2 limit x approaches 0 minus sin inverse x by minus and minus will cancel x plus 2 into minus here I can put x as 0. So I will have pi by 4 limit as x approaches 0 minus sin inverse x by x. This is 1. This becomes 1. So it is pi by 4. So left limit is not equal to right limit. Sure. So function is not convenient. We cannot find alpha. The main question is to find alpha. So no such alpha exists. Question 3. I'm putting the next question. This question is not yet complete. Here is the question. According to the question, f of x piecewise function, g of x piecewise function is given. If G circle f of x is continuous, then a plus b equal to. So we have to make the function g of f of x a piecewise. So first we will make for x less than 0. G of f of x. Less than 0 means I will write f of x as x plus a. Less than 0 means x plus 1. So x plus a plus 1. So it's x plus a plus 1. Next is we will take x greater than or equal to 0. For f, if you take greater than or equal to 0, mod of x minus 1 is a piecewise function x minus 1 for x minus 1 greater than or equal to 0. That means x is greater than or equal to 0. and minus of x minus 1 for x less than. So next is we have to take x greater than or equal to 0 and less than. So g of greater than or equal to 0 is here, less than 1 is here. So I have to take 1 minus x. For greater than or equal to 0, we can take this function for g. In place of x, 1 minus x minus 1 whole square plus. So 1 and minus 1 will cancel. X square plus b. X square plus. Next, we have greater than or equal to 1. When you take g of greater than or equal to 1 means I will take x minus 1. And greater than or equal to 1 means I have to take x minus 1 minus 1 whole square plus 3. That is x minus 2 whole square plus 3. So this is how I get piecewise function. For G circle f of x. It is continuous. This piecewise function is continuous. What does it mean? Left limit is equal to right limit. At x equal to 0, we will see. So a plus 1 equal to b. Or a minus b equal to minus. Then we will see at x equal to 1. B equal to, because we are seeing x equal to 1, 1 plus b equal to 1 minus 2 minus 1 whole square. So here this is not helpful. X equal to 1 is not helpful. Then what? In both the cases, we are getting same. So this method is not applicable directly. Then how to find the piecewise function? Everything depends upon the piecewise function. So making piecewise function is important. So first we will take G of f of x, piecewise function. First we will bother about f of x because f of x is the inside function. When f of x is less than 0, this inside one is less than 0. What we will have in G, we have to make G f of x plus 1. See the G function, x is less than 0. I have taken f of x less than 0. So x plus 1 became f of x plus 1. Next, we will take f of x greater than or equal to 0. Here x, f of x. So we have f of x minus 1 whole square. And then plus 3 as the function. Now in the next step, the same piecewise function. F of x. We can take x plus a plus 1. Provided we have to write x is less than 0. And if x is less than 0, x plus a is also less than. That's okay. Now for mod of x minus 1. We have x minus 1 when x is greater than or equal to 1. 1 minus x for x less than. Because we are talking about G now. And f of x greater than or equal to 0. So when x is greater than or equal to 0 and less than 1. Which one we will take? We are breaking it into two. Here, f of x is less than 0, f of x plus 1. So we have written the first function. But f of x greater than or equal to 0. This we are breaking into two parts. One is mod of x minus 1 less than 0. But x will be greater than or equal to 0. Then the function will be mod of x minus 1 plus 1 in this function. Whereas the other one is x plus a greater than or equal to 0. But x less than 0. For that, we will have x plus a, this function, x plus a minus 1 whole square plus b. The last one is mod of x minus 1 greater than or equal to 0. Of course, x will be greater than. So it will be mod of x minus 1 minus 1 whole square this. So I hope you have understood this point. Once you understand this, we can write the next step, g of f of x. The first one we will take x in the interval minus infinity to minus 8. Union minus infinity to 0. Both. Then in such case, the first function as it is we have written x plus a plus. Then x belongs to the empty set. No x is such that we have mod of x minus 1 plus 3. That second issue you can use. Coming to the third one, x is greater than or equal to minus a. X is less than 0. For this, the piecewise function will be x plus a minus 1 whole square plus b as it is. Then the last one, x is greater than or equal to 0. It is mod of x minus 1 whole square plus. Or we can simplify b of f of x as, first piece will be x plus a plus 1. X is lesser than or equal to minus a. X is greater than 0. Actually, you can avoid this greater than 0 also. Just x less than or equal to minus 0. Equal to also we can remove because we did not take equal to in the previous step. And now x greater than or equal to minus a and less than a. That will be x plus a minus 1 whole square plus. Lastly, x greater than or equal to 0. It is mod of x minus 1 whole square plus. Now, the function is continuous at x equal to minus. That means left limit is equal to right. Left limit is minus a plus a plus 1. And right limit is 1 plus 6. So we get b equal. Next, we'll see at x equal to 0. The left limit is a minus 1 whole square plus b. And right limit is 0 plus. So we have a minus 1 whole square equal to 0. A minus 1 equal to 0, a equal to 1. So a plus b is 1 plus b. They're asking you what is it. or we can say A plus B is, that is what it is. Next, if the function f of x is continuous and f of 0 is 1 by k, then k is continuous means limit of cos of sin x minus cos x over by x power 4 as x approaches 0 is f of 0. Now, how to find the limit here? We have to use transformation. Cos c minus cos d. Two sin c plus d by 2 sin d minus c by 2. Denominator is x power. Still, how can you simplify this? I will first of all take 2 and then sine of sine x plus x by 2 sine of x minus sine x by 2. And then down I have x power. So in numerator, I'll multiply x and x cube here. In denominator also, I have to divide by x power. Numerator, I have divided by x power 4. Denominator, I am dividing by. Then the limit becomes limit as x approaches 0. 2 into sin x plus x by 2x Sign off. Here sign off. Then here also. I'll remove the signs actually. Sign doesn't have any space. It is becoming more complicated. So 2 into sin x plus x by 2x and x minus what? Sin x by 2x. So this has to be equal to f of 0. F of 0 is given as 1 by k. So on the right side, you will be writing 1 by k. So now when you take the limit, you'll write 2 into sin x by 2x plus 1 by 2 into 1 by 2x square minus sin x by 2x. If you find the derivative, that would be more better. If you apply L'Hopital's rule for both, that will be more easier. That is cos x plus 1 by 2, 1 minus cos x by 6x squared equal to 1 by. So here I will have 2 into cos 0 is 1 plus 1, 2 by 2. But here I have to apply L'Hopital's rule again for this part. Sin x by 12x equal to 1 by 2. So here 2 into limit, apply L'Hopital's rule, cos x by 12 equal to 1 by 2. 2 into put cos 0, 1 by 12 equal to 1 by 2. Or we have 1 by 6 equal to 1 by k. That means k is 6. So the value of k will be 6. So in this way, we have done up to question number 4. Next class, we will complete